Hello all. As a continuation of our lecture series in control systems, today we are going to learn about mechanical translational system. From the name, mechanical is we use some mechanical components, whereas in electrical components we tell it as resistor, inductor, and capacitor. Whereas coming to the mechanical component, we use the words like spring, mass, and dashpots. And this mechanical system, we have again two types, which is translational and rotational system. So in which we are going to learn about the translational system. So translational system is a linear motion, front and back. Whereas coming to the rotational system, so it is a rotating part. For example, we can tell it as a motor, which is a rotational system. So here we have a picture for the mechanical translational system. So before going into this topic, let us recall about what is open loop and closed loop. So differentiate open loop and closed loop system. So open loop system, there is no controller and the effector purpose. Whereas in the closed loop system, using the controller and the effector, we get the desired output. Whereas in open loop, obtaining the desired output is not possible. So some of the examples for open loop and closed loop, which we have already learned in the previous video, like bread toasters, hair dryers, traffic light signals, all these comes under open loop system. Whereas in the closed loop system, we have some examples like water level indicator and air conditioners, geysers, everything comes under the closed loop system. So topics for discussion. So now let us have an introduction and elements and free body diagrams and applications of mechanical translational system. So in this picture, M1 and M2 indicates the mass, which is nothing but the weight. And K1, K2 indicates the spring, and B indicates the dashpot, which is the damping process. And X1 and X2 indicates the displacement due to the force F. So if a mechanical part is given a force F, there will be a movement linear in motion. So that's why it is called as translational system, and that linear motion is mentioned as X1 and X2 here, which is we call it as displacement. So here we have a simple example like at rest, how is the position, and when ground moves upwards, how is the position of the spring, and when ground moves down, how is the position of the spring. So the dotted lines indicates the weight which stays at the same level while the ground moves. So ground is moving whereas the weight is at the same level. So the weight is hanged through the spring. So when the ground level moves up and down, the spring compresses and expands by itself. So coming to the introduction, dynamics of the motion, force analysis, energy transport, and system optimization. So this is the process of mechanical translational system. So these concepts are specific to mechanical systems and are crucial for understanding mechanical translational systems. And coming to the ideal elements, so we talk about displacement, which is x and which is measured in meters, and velocity is change in displacement with respect to time. So that's why it is mentioned as dx by dt. So when time comes into the position, so the unit changes to meters per second. Whereas in acceleration, which is mentioned as a, which is change in velocity with respect to time. So again, it is to be mentioned like dv by dt. So instead of v, we can substitute dx by dt. So then it becomes d square x by dt square. So coming to dt square, then the unit changes to second square. So when we have to apply a force. So applied force is F, and which units is Newton, N. So opposing force by the mass, spring, and damping, dashpot, which is friction. So mass is Fm, spring is Fk, and friction is Fb. So now let us solve a problem. When we solve a problem, we use all these coefficients. So stiffness of the spring, we mention it as K, and the friction coefficient, we mention it as B, and mass, we mention it as M. So since mass is the weight of the system, it is measured in kilograms. So the first process when we are given with the problem of mechanical translational system, and that we have to change into a transfer function. So the first process is we have to identify how many how many dash, how many spring we have in the problem. Okay, so after which the first step will be drawing the free body diagram. So whereas free body diagram indicates what are all the force that on that particular mass. Okay, so free body diagram indicates what are all the mass or what are all the forces which acts on the particular mass. So when we go with mass, it will have its own mass, so we have to include that also. If it is m1, then we have to include the force of m1 also. So this free body diagram is very essential for deriving the equation of motion, and it isolates each mass in the system, and we have to draw all the forces acting on the mass and choose a consistent coordinate system. So what is the purpose of modeling of mechanical translational system? This is the main purpose is to analyze the dynamic behavior and to determine the transfer function and analogies with electrical systems and control techniques and applications. So this is the main purpose of modeling of a mechanical translational system. So let us summarize today's session. We have introduced what are all the mechanical components and what is translational and rotational system. Coming to mechanical components, mass, dashpot and spring, and a best example like what happens to the spring even if the weight does not change when the ground moves up and down, what happens to the spring, and that after that purpose of modeling has been done. So in order to determine the transfer function, the first step is to draw the free body diagram and determine the equations. So coming to the assessment, which element in a mechanical translational system stores kinetic energy, that is mass, and the force developed by the spring in a translational system which is proportional to the displacement. And this is these are some of the references of mechanical translation system. Let us meet in the next video. Thank you.